Math 95. So I'm back with another video working through a couple more pages of those guided notes. So where we left off last time, at the bottom of page 2, there was the grid, and then you were going to take the 6 points on the top of page 3 and graph them. So here's what those 6 points should look like on your graph. Okay. So A was 4, 2. That means we're going to go right 4 and up 2. B was -1, 3. So -1 tells us to go left 1, up 3. C is -4, 0. So we go left 4, and then 0 for the y coordinate tells us we don't go up or down at all. D is -2, -3. E is 0, 5. These are the ones that people tend to have the most trouble with. People see that 0 and kind of skip over it in their head and say, oh, we're moving 5. But remember, the 0 tells us 0 left and right, up 5. And then F is 2, -4. Okay. So hopefully you got those correct for the graphing. One other thing that we didn't mention the other day is that you can see that the axes split this graph, this grid, into 4 parts, and we call those quadrants. Quad, kind of like quadruplets, right? Same root. So quadrants. Right? And so we number them with Roman numerals. This is quadrant 1, this is quadrant 2, down here on the left is quadrant 3, and the bottom right is quadrant 4. Okay, so 1, 2, 3, and 4. And I remember which way they go because if you start out with writing a C and you start here and go around in a circle, that's the direction that they go. All right, so now we want to get back to what we were talking about earlier about this equation x plus y equals 6. And I said we were going to see how that equation relates to a graph. So now that we've reminded ourselves how to graph, let's go back and look at this equation again. I'm sorry, that glare is right there in the way of my light there. It's from my light. So I'll just write this again down here. X plus y equals 6. Okay, so what we want to do is, if you notice on the notes, I have filled in values of x here from 1 to 6. Okay, we want to fill in the y value that goes along with each x that makes this true. So in other words, if x were 1, I could figure out what y value would have to be here to make this a true statement. 1 plus 5 is 6. So 1 and 5 together, 1 plus 5 makes this a true statement. Okay, same with 2. So 2 would have to add to 4 to make that true. Okay. 3 plus y. And if these were larger numbers and you couldn't do it in your head, think about how you could get y by itself. You could subtract. Probably don't need to do that with these because they're smaller, but you certainly can. So 3 plus 3 is what's going to equal 6. 4 plus 2. 5 plus 1, and 6 plus 0. So in each case, whatever x value was, we found the one y value that would make that a true statement. So now if we put them together, here's our ordered pair format. We can put it together as an ordered pair, always x and then y. So 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, and 6, 0. Okay, so now what I would ask you to do is to pause the video for a minute and either on your notes, if you have them printed out, or on a sheet of paper with just a little grid sketched into it, go ahead and graph these points. If you have the notes, it's on page 4 on the next page. So go ahead and graph all of these points. You don't have to label them in this case. Just go ahead and graph those 6 points. And then come back to the video when you have done that. Okay, so hopefully you paused the video and took a minute or two to graph those points. So let's see where they should be on here. So if we graph these, we're going to graph 1, 5. Now it's a little bit small, I'll bring it up in a second. 2, 4, so over 2, up 4. 3, 3, over 3, up 3. 4, 2, 5, 1, 6, 0. So hopefully you see that you have a straight line of points, okay? Those points made a straight line. Now, if we had something wrong, let's say we said x was 1, we said y was 12. Well, 1 plus 12 clearly doesn't equal 6, so that would not be correct. And if I graphed 1, 12, it would be way off of this line. But these points together, we can see, make a straight line. We can use a ruler or just an edge of another piece of paper or something to connect them to make a straight line. Mine's not the neatest because I have this big old marker. And then we want to label it with our line, with our equation. So what this means is that every single point on this line, not only the ones we graphed, but all the little fractions and decimals in between also, would make this equation true. If I took any x value, even if I took 1.5, figured out what my y value was and plugged it in, that would equal 6. It goes on forever. You can see that it has arrows on the end. Okay, so this is the graph of this equation. Now this is what we call a linear equation, and we've talked about this a little bit earlier in the semester. But we can see the word linear here has the word line right in it, right? Linear equations make straight lines. This is a linear equation because x and y are both to the first power. There's nothing crazy like a square root or an absolute value. We'll get to those actually a little bit later this chapter, to not square roots, but to absolute values and to some equations that are not linear. But when we have a linear equation, it makes a straight line. Okay, so we filled out our chart, we graphed it on the next page, talked about linear equations. All right, so this is what we call plotting points, okay? Where we start with values of x, we figure out what values of y match that for that equation. There are other ways to graph linear equations. We'll talk about those in chapter 6. But in chapter 5, we're concentrating on this plotting points method because it does work for not only linear equations, but more complicated equations also. Any equation you get, you could use this kind of method for. All right, so x plus y equals 6 was a simpler equation. Okay. But what if we have an equation like this? The next one is 4x plus 2y equals 12. So what we want to do to make this easier to work with is to solve for y. And if you remember, we did this back in chapter 3 when we were solving equations. We would solve for one variable or the other when there was more than one equation. We move things around the same way we normally do, but remember we can't combine things if they're not like terms. So I want to get y by itself. So I'm going to subtract the 4x from both sides. Remember, once on each side. If it helps you, put that line down the middle. So I'm going to get 2y equals. Now I could write 12 minus 4x. That's perfectly fine. We're going to start getting in the habit, though, of always writing the x term first, because that will help us when we get to chapter 6. So I have negative 4x. And then because the 12 here is positive, I'm going to write plus 12. What I can't do is say 8x. I can't combine these, right? Because this one does not have an x, and this one does. They're not like terms. So now I want to get the y by itself. Right now y is being divided by 2, or sorry, it's being multiplied by 2, so I gave it away. I want to divide every single term by 2. Every term. Even if there was one, whether they have x's or not, it doesn't matter. So y, because 2 divided by 2 is 1, so I just have 1y equals negative 2x plus 6. So now I have this in this format where y is by itself. That makes it much easier, because now when I plug in values of x, I can just plug it in here and then use order of operations just on this side, and boom, I get the answer for y. So I am going to make a little bit bigger chart here. So I'm going to have this little workspace area in the middle. You can see this on the notes. You don't always see this last column with the x, y as an ordered pair, but it kind of helps when you're getting used to it. Otherwise, you could just read them off from x and y. So we can, excuse me, for a linear equation, because every value of x would work, we can use any values of x we want. We could put in there negative 463, and then we could get a value of y. However, x equals negative 463 is way down here. So we use values of x that are along in here so they're on our graph, okay? So generally, I'm going to say to use negative 2 up to positive 2. Okay, so what we're going to do is when x is negative 2, let's plug it in here. Negative 2 times x, which is negative 2, plus 6. Well, negative 2 times negative 2 is 4, so that's 4 plus 6, so my y value is 10. So when x is negative 2, y with negative 2 substituted in here would equal 10 for this equation. Then I do the same thing for negative 1. Plug negative 1 in for x. So this is 2 plus 6. It's going to be 8. So go ahead, pause the video for a minute, and I'd like you to go ahead and fill out these 3 lines with the workspace and the y value. Okay, and pay attention to see if you see a little bit of a pattern also. When you're done with that, you can pop back into the video. Okay, so hopefully you filled out these 2 columns here. I'm just finishing mine. So when I plug in 0, I get 6. When I plug in 1, I get 4. And when I plug in 2, I get 2. So do you see a pattern here? Every time x goes up by 1, y goes down by 2. Up by 1, down by 2. All the way that pattern stays consistent. That's what gives us a straight line instead of a curve. So if that changes along the way, then that's what give us a curve. But since there's a consistent pattern there, that's what gives us a straight line. So now let's go ahead and make our ordered pairs. Okay, and then you can go ahead and graph those. So this is the graph that would be on page 6. So what I'm going to do is I'm going to graph this on here. When you're done, you can start the video again and check your answers. And then I'm going to stop this video there. And I'm going to do the other 2. I'd like you to try the other 2 on 7 and 8, pages 7 and 8. Those are for you to try. And I'll put up just a short video with the solutions to those. Okay, so you can stop the video, graph this one, check your answer quickly, and then you'll be done with this video, and then you can go ahead and try the other 2 on your own. Okay, so I hope by the time you're back here, you've done this graph that we had up here. So we have negative 2, 10, negative 1, 8, 0, 6, 1, 4, 2, 2. Again, you can see that my dots are making a straight line here. So I can use my ruler or some kind of straight edge to make a straight line. Put arrows. Oops, my line kind of a little tricky with this marker. Put arrows on the ends. And then we label it. We can either label it with this version of the line, that's the one I tend to use, but you can also label it with the original. That's fine. So I tend to say y equals 2x, negative 2x plus 6. And make your line big. I really could have even extended it out farther. It can extend out farther than where your points are because the line goes on forever. One thing I want to point out is that sometimes in your chart, you'll end up with points that are too tall or too small to fit on your grid. So you might end up with one that says 1, negative 12, okay? Please do not draw extra little boxes on your graph. You only technically need 2 points to create a line. So let's pretend our graph only went up to 8. You could just not graph this one and just graph the ones that fit there, and that's fine. Okay, you'll find that with a couple of these coming up. All right, so you can go ahead and try number 7 and 8 on your own, and then I will put up a short video just with the answers to that. All right, thank you.